so really quickly, let's write some things in scientific notation. Well, actually, before that, why do we have scientific notation? Zach?
Because you don't want to write a number with like a million place values.
You don't want to write a number with a ridiculous number of place values. So we're talking about numbers that are really super big. Like, how far are we from the nearest galaxy? That's a really big number, isn't it? Or we're also talking about numbers that are really, really, really super close to 0. I don't want to say small because negative numbers are smaller than numbers close to 0, but we're talking about numbers that are, say, what is the mass of a hydrogen atom? That's really tiny, isn't it? So we're talking about numbers that, if written in standard form, are really difficult to read or write because they have so many zeros. So let's take this number to start with. And I'm not going to start with a number that is really ridiculous. Let's start with 4 million. And we're going to write this in scientific notation. And out of curiosity, how many people here have done Mad Libs?
I've done what?
Mad Libs. Have you done a Mad Lib?
A what? Mad Libs. I don't think so.
Oh, that is a deprived childhood right there, folks. All right. So this is just like a Mad Lib, but it's not nearly as funny, and there are no bathroom humor in it either. I know, very disappointing. I know everyone did that. Like, no, you can't use that word again. All right. So here is our Mad Lib. In scientific notation, you will have one number that is not 0 to the left of a decimal point. And then typically you'll either have 1 or maybe 2 numbers to the right of the decimal point. You will always have the multiplication x. This is the only time the multiplication x is okay. And then we will always have times 10, and there will be an exponent here. We need to fill in the blanks, just like a Mad Lib. Yes, Eliana? Not yet. Not yet. All right. So before we get started, is this number large or really close to 0? It's large. OK. So does that mean we're going to have a positive exponent or a negative exponent? So if we're taking a large number and turning it into scientific notation, we are going to have a positive exponent. Yesterday we talked about negative exponents. What do negative exponents give us? Fractions or decimals. Fractions or decimals. So if we have a number that has a decimal and a lot of zeros after it, then we're going to be using a negative exponent. So that's a good way to think about it. Is everyone with me so far?
Yes.
OK. So now 4 million has a decimal place here. I need your help. I'm an algebra teacher, which means counting is not my forte. Can you help me count? OK, here we go. Ready?
1, 2, 3, 4, 5, 6.
OK, so 6. Where does the 6 go in my Mad Lib format? Where does the 6 go, Sai?
The exponent?
It's the exponent. So then what number goes here?
4.
4. What number is going to go right here? Kind of a trick question. 0. All right. And so now I could put another 0 here, but we don't always have that term. So now we have 4 million written in scientific notation. Yes, Sawyer?
Wouldn't it be a negative 6?
No, it would not be a negative 6 because the positive. So essentially what we're doing is when we move the decimal place over, we are dividing this number by 10. So if we're dividing this number by 10, in scientific notation, we need to compensate for that by multiplying by 10. So that's what's happening here. Yes, Eliana? If it's 4,076,000, I would probably put the 7 and the 6 here. But here's the thing. Let's say I have this number. $4 billion. here's the question. How much does 73 million matter when we're talking about a number that's 4 billion large? Not really. Not a whole lot. We're talking about numbers that are so big that by rounding, we're really not making a big difference here. I mean, if you look at your bank account and hopefully when you retire you have a couple $1 million, what's a few cents? It doesn't really matter. I'm hoping for the best for you. All right. One more. If I'm writing it, what are you doing? I don't know. How many zeros do you see? So I'm going to set up my Mad Lib. I'm going to set up my Mad Lib again. Blank dot blank times 10 to the blank. Are we talking about a big number or a number really close to 0? We're talking about a number that's really, really, really close to 0. So are we going to have a positive or a negative exponent? A negative exponent. Okay, so we know, I'll just go ahead and put the negative here. All right, so here we go. Again, I need your help. David, if I can't hear you in the video, I know you're not doing your best here. Okay, here we go. Ready?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
No, not 12. No, not 12. I know, you're in the moment, you're excited. It's okay, it's okay. Because you have to have one number to the left of the decimal place. So we would have 7.6. And what is our exponent?
11.
Negative 11. So that was our basic reintroduction to scientific notation. The last thing I would like you to do on your calculator this time is this. I would like you to take 72, and I would like you to take it to the, ninth power. Go ahead and take 72 to the 9th power. There's a calculator right in front of you, goofball.
Well.
I mean, it's now on your desk. It's a lot of numbers. That would be a true statement. Yeah, are you getting something funky on your calculator? That's exactly what I was hoping for.
I got 5.1.
No, my goodness, no. Just here's how you use it, right? So you go 72, and then see this caret button, and then you hit 9.
Oh.
And there you go. This is much easier, much easier. All right, how many of you got a number that looked something like this? You had 5.199. What came after the 9?
6.
Okay, it goes on, it continues, and then you had something that said E, and then after the E, it had 16. How many of you had something like that? That should be all of you.
Mine didn't say the E though.
It didn't say E. What did it say? Okay, Molly, you're special. You have a special calculator that already writes it in scientific notation.
Yeah, mine did that too.
Okay, so Molly and Finn are special, but nobody else. All right.
Oh wait, no it didn't. I lied.
Okay, Finn's not so special anymore. This is what has happened. The calculator does not have a long enough display to show the number. So it is giving you the number in scientific notation. So we have, just like our normal little thing, we have 5 point, what am I going to put here? 2, right? I'm going to take that and round. Normal rounding rules apply. Times 10. And what is my exponent going to be? 16. This is my exponent. This E is really just saying times 10. And then the number after the E is the exponent. Are there any questions on how calculators show scientific notation? E means times 10. Specifically, it means times 10. All right. So are we all good so far? So yours does show it. Yours does show it, Finn. But it doesn't say E. It just gives you the exponent. All right.